Good morning, class. Good morning, everyone. Am I audible and visible to all of you? Great. Good morning, bacho. Good morning, everyone. So, how's the preparation going on and how was the test? So, you were able to do the test properly or not? There were some theoretical questions in that test. So, was that okay with you people or not? Good morning, everyone. Good morning. Nice one. Okay, great. That's good. That's really good. Good morning. Sir, could you once explain that degenerate orbital question? I can explain that. So I told you that in one electron species, like say hydrogen, helium plus, and like say lithium 2 plus, it is the only n value which will determine the energy level. And if I'm talking about the third shell will contain 3s, 3p and 3d. So they are all having equal energy. All these subshells are having equal energy. Okay, Sham Pulao. You're doing good. I saw your marks out there. You're doing good, Sham. Keep it up. So, like it contains one orbital, it contains 3 orbital, and it contains 5 orbitals. Right? All of them are having same energy level. So the degeneracy level is what? The number of orbitals having the same energy level. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the degeneracy level will be 9. Vijay, clear? Clear now? Yes or no? चलो ठीक है. Okay, we'll begin the mole concept. भैया ये important है. This is an important topic, a very important topic, the base of everything. Okay, it is a very strong pillar of entire physical chemistry. So if you do it properly, I believe that you will be doing great in other chapters as well. Because on this platform of mole, if you do mole properly, I can tell you what you can do properly, easily. I mean later on, the first thing you can do properly will be thermodynamics. Then you can do chemical equilibrium, ionic equilibrium, electrochemistry, solution chapter, surface chemistry, solid state. All these chapters are all based on mole. Are you getting it? So if you do it properly, these are yours. That is nothing but entire chapter. I mean entire syllabi of physical chemistry. So do it properly and do it with passion and flair. Okay? Chalo, aajao. So let's begin. We'll begin straight away. So see, the first thing you should know about the mole concept is that weight of one proton is almost equal to weight of one neutron, which is actually equal to 1.6 into 10 to power of minus 24 gram. This is nothing but 1 AMU, 1 atomic mass unit. This is nothing but 1 atomic mass unit. Okay? Acha, we all have been taught earlier that 1 AMU is equal to weight of one atom of carbon 12 isotope divided by 12. This is what we have been taught. So this is nothing but what I have written earlier. See that stuff? So one atom of carbon 12 will contain 6 proton and 6 neutron, and weight of an atom is all due to the number of protons and neutrons. Electrons are neglected while counting the weight of an atom. Okay? So divide by 12. Now you all know that weight of one proton is equal to weight of one neutron. Can I say this will be equal to 6 proton plus 6 proton? I'm replacing the weight of neutron by proton. One and same thing upon 12. This can be equal to 6 neutron plus 6 neutron upon 12. Either way you can say that this will be 12 proton upon 12, or you can say which is equal to what? 12 neutron upon 12. So this happens to be 12 and 12 cancel up. This is equal to 1 proton or weight of 1 neutron. So what is 1 AMU? Same thing which I have wrote earlier. What is 1 AMU? Weight of 1 proton and 1 neutron. Okay? Chalo, aage badhte hain. Let's do something more. Also remember one thing, that 1 AMU into Avogadro number will give you 1 gram. Will give you 1 gram. बहुत important, very very important. है ना? See, I can tell you that stuff. I can tell you that stuff. See, 1 AMU is what? 1.6 10 to power of minus 24 gram. And what is Avogadro's number? 6 into 10 to power of 23. And you will see that they will cancel up almost. You'll get 1 gram. The gram will remain, na? The gram will remain. So it will be equal to 1 gram. Actually, 1 AMU and Na, numerically they are reciprocal of each other. They are reciprocal of each other. ठीक है now. See, one more thing. 1 AMU means atomic mass unit. This is the unit of measurement of weight in the micro world. In the micro world. Are you getting it? And this is the unit, sorry, not this one. This is the unit of measurement in macro world. In macro world. Macro world means our world. The world in which we live. We can feel the gram. We can measure in terms of gram easily, but we cannot feel the AMU. We cannot measure in laboratory as such plainly in terms of AMU. Are you getting it? The thing is that the reactions occur in the micro world between atoms and molecules, but we can't see that micro world. But we, being a science student, we need to observe that. We'll observe that experiment where? In the macro world. So we need to take some measurements. So somehow we have to convert all those things occurring in the micro world into what? Macro world. So that thing is nothing but a switch. That is called Avogadro's number. You press this switch, you will move from micro to macro world. And from macro world to micro world if you divide by the Avogadro's number. So it's a switch you can use to convert yourself from micro to macro world. Is that clear? Chalo, theek hai. So what I'm saying, if I say, talk about hydrogen atom, and I say that I am in the micro world, and I want to go into macro world. So I'll do what? I'll multiply by Na, and in the micro world, the weight of one hydrogen atom is how much? It is actually equal to 1 AMU. Is equal to 1 AMU. We all know that stuff. This one is what? Basically the mass number. And mass number is total number of protons and neutrons which are responsible for the weight. So your atomic weight or the weight of an atom is equal to number of protons and neutrons mentioned in terms of AMU. And if I want it, multiply by Na, I'll get 1 gram. So what do you mean by when I multiply by Na? That I will be collecting hydrogen atom. How many number of times? Avogadro number of times. When I collect it Avogadro number of times, I'll get 1 gram. Is that clear? Similarly, let me have, say, carbon 12. It will have a weight of 12 AMU. One atom of carbon has a weight of 12 AMU, and if I multiply by Na, I'll go from micro to macro. It will become what? 12 gram. Is that clear? Similarly, suppose I'm having maybe H2S. H2S has, like, say, 34 as its molecular weight. So this will be 34 AMU. 34 AMU in the micro world, and into Na will give me 34 grams. Yes or no? So what we have learned right now, if you want to convert micro into macro, multiply by what? Avogadro number. It's a switch you will use to convert the micro species into what? Macro species. As simple as that. Okay? So one more thing I want to tell you what. Weight is the least important thing in the world of physical chemistry. The most important thing is number. Entire periodic table is based on what? A number called atomic number. The weight of basically the element depends on its mass number. What is 1 mole? It's a number. What is that? Avogadro number. So you will find that physical chemistry will be focusing more on numbers. Weight is the least important thing. Weight is most important where? It is most important in the world of physics, but not in terms of physical chemistry. Are you getting it? Achha, dekho. This number is the ID. This number is the fingerprint. Are you getting it? This nucleus is the fingerprint. I'll tell you why I'm saying so. So if I say 1, you will tell me, sir, I'm talking about hydrogen. If I say 4, you will tell me that I'm talking about what? Helium. If I say 16, I'm talking about whom? Oxygen. 12, carbon. Are you getting that? So you are able to tell which element I'm talking about based on these numbers. Numbers are very, very important. Very, very important. है ना? So one important number is atomic number, another important number is mass number, yes or no? And they all reside where? These neutrons and protons, they reside where? In the nucleus. So nucleus is actually the fingerprint, the Aadhaar card of an element. The moment I say that I am, like say this is sulfur. Sulfur contains 16 protons and phosphorus contains 15 protons. Just by changing one proton, the identity of the element changes. From sulfur it becomes phosphorus. Are you getting it? So I can't touch the nucleus. Are you getting it? See, a simple activity of cutting, which is very normal in our world, is not allowed in the micro world. You simply cannot cut it. See, I have taught you atomic structure. I have taught you that micro world is very weird. It does not follow any of the rules in the macro world. Yes or no? Including that Heisenberg uncertainty principle, if you see that, and a de Broglie wavelength, you see that, Schrodinger wave equation, see that, they are all relevant where? In the microscopic world. Yes or no? Yes or no? Okay. Now I'm telling you, if in your world I cut a potato, I'll get 2 tomato or 2 potato. If I cut a potato, I'll get 2 tomatoes or 2 potatoes. If I'm cutting a potato, I'll get 2 potato or 2 tomato. I'll get 2 potato. Yes or no, bhai? But in the micro world, if you will cut a potato, you get 2 tomatoes. You'll get 2 tomatoes. I'll show you. See, for example, this is the atom of sulfur. Sulfur contains 16 proton and 16 neutron. This is sulfur. Yes or no? If you cut basically a sulfur atom into 2, you will get what? 8 protons, 8 neutrons. 8 protons and 8 neutrons. This is what? Oxygen. This is actually oxygen, yes or no? So on cutting sulfur, you are getting what? Oxygen, not sulfur. Yes or no? The act of cutting is not allowed in the microscopic world. Yes or no? So on cutting a potato, I am getting 2 tomatoes, 2 oxygen atoms. Is that clear? So the point is that if I ask you minimum possible weight of sodium will be how much? Who will tell me the minimum possible weight of sodium? Minimum possible weight of sodium will be what? 1 atom? Because half atom doesn't exist. Half atom doesn't exist. Either it is 1 atom or 2 atom or 3 atom. So minimum weight you can give me is what? Gautami, very good beta, very good Gautami. Very good Pavitra, very good, excellently good. That's a magical word. That's a magical word. No, Zamir Sheikh, we cannot have 1 AMU. Minimum, no, BE2, we cannot have. We'll have exactly, bache, very good. Sajid, very good. Shyam, very good. Kavita, very good. Yes, it will be 23 AMU, 1 atom. Minimum thing of sodium you can give me is 1 atom. And 1 atom contains 23 AMU. Are you getting it? Chalo batao. Carbon, minimum weight of carbon you can give me is how much? 1 atom of carbon. And that will be equal to what? 12 AMU. 12 AMU. Yes or no? Very good. Chalo batao. Who will give me minimum weight of oxygen? Minimum weight of oxygen. Come on. 16 AMU, I believe. Am I correct or not? That's good. That's very good. Achha, if I say I am giving you 1 AMU of oxygen, is it correct? Is it correct? I am giving you 1 AMU of oxygen. Is it correct? No, it's not correct. It's not correct. So if I give you 1 AMU, I am giving you what I am giving you actually. I am a fraud who is giving you what? Hydrogen. Who is giving you hydrogen? Yes, very good. Very good. Very good. So let's do a question basically. So the question says that find number of helium atoms. Find number of helium atoms in 64 AMU. In 64 AMU, find the number of helium atoms. I know that 4 AMU will contain one helium atom. 64 AMU will contain 64 by 4, that is equal to 16 helium atoms. Yes or no, bhai? Is that clear to all of you? Yes or no? चलो बताओ, एक और क्वेश्चन करो. फाइंड नंबर ऑफ oxygen atoms. Find number of oxygen atoms in 8 AMU. Come on. Find number of oxygen atoms in 8 AMU. Be quick. Correct, Gautami. Very good. But yeah, the people who are giving the answers 1 by 2. 1 by 2 atom is simply impossible. 1 by 2 oxygen atom doesn't exist. Or it doesn't exist. It is not possible. Minimum possible weight of oxygen is 16 AMU. 8 AMU is not possible. Not possible. Half atom doesn't exist. That's what I'm saying. We study, we learn, but we don't execute that stuff. Minimum weight which can exist for oxygen is 16 AMU. Is that clear or not? Getting that? Yes or no? So I'm telling you, you're still not good at playing googly. Chalo, come. Okay. Now come over here. Let's see one thing. Let's take about some element and let's talk about its atomic weight, and let's talk about the micro world, and let's talk about the macro world. है ना? So if I take element as H, what is the atomic weight? 1. And in the micro world it will be what? 1 AMU. Atomic mass unit is the unit of measurement of weight in micro world. But if I multiply by Na, I'll get what? 1 gram, and I'll come in what? Macro world. Gram is a unit of my world. Okay. Similarly, carbon 12. Bolo bhai. Atomic weight will be 12, and this will be 12 AMU. And in the macro world, it will become 12 gram. Say again. Let's say what you can say. Oxygen 16 AMU, and into Na, and I'll be having 16 gram. So you can see that atomic weight is having no unit. Actually, it is actually relative atomic weight. This is actually beta called relative atomic weight. Are you getting it? And atomic weight expressed in terms of gram. Atomic weight expressed in terms of gram is called gram atomic weight. It's called gram atomic weight. Is that clear or not? Atomic weight expressed in terms of grams are called gram atomic weight. Acha, if you have seen any question of mole concept, है ना? In any booklet, if they give you the atomic weight of oxygen is given as what? Like 16 AMU or 16 gram? 16 AMU or 16 gram? In the questions, what you have seen, that they give you normally 16 gram or 16 AMU? No. They don't give you AMU or gram. They simply give you number. And now they give you liberty. That if you want to work in the micro world, you can use 16 AMU. And if you want to work in the macro world, you can use 16 gram. The mathematics remains same. The number remains same. Only units get changed. Is that clear to all of you? Atomic weight actually is a number. It's a relative atomic weight. It's a relative atomic weight. I'll share that. So if someone asks you what is relative atomic weight, relative atomic weight is what? Weight of one atom. Weight of one atom of an element. Of an element divided by weight of one atom of carbon 12 divided by 12. This is something you must have read earlier. That what is relative atomic weight? Relative atomic weight is defined with respect to carbon atom. And what is that exactly? Weight of one atom of an element divided by weight of one atom of carbon 12 divided by 12. Now, acha, what is this thing? What is this thing? What is this thing? We have just done that. 1 AMU. So suppose that I'm talking about relative atomic weight of oxygen. Atomic weight of oxygen. It will be like weight of one atom will be 16 AMU. And this is what? 1 AMU. They are all cancelled up and it will be like say 16. It is a unitless entity. It is a unitless entity. That means now if someone is there, suppose that Zamir wants to work in microworld, he'll be using 16 AMU. And if suppose we have Gautami wants to work in the macro world, we can have 16 gram. The identity, the ID, the Aadhaar number remains same. Aadhaar number should not change whether you're working in the micro world or in the macro world. Is that okay? 15 means phosphorus, 16 means sulfur. Number of protons I'm talking about. So be careful with that. Shall I? Similarly, bachcho, if I go with the molecules, let's talk about the molecular weight, let's talk about the micro world, and let's talk about the macro world. Multiply by Na. So molecule I'm taking, bachcho, is say we can have CO2. So what is the molecular weight of CO2? 44. In the micro world, 44 AMU. And in macro world, come on, 44 grams. Yes or no? Everyone. And we have H2S. What is that? 34. 34 AMU. And into Na, you'll get 34 grams. So your molecular weight is also unitless because it is again measured with respect to carbon 12. And molecular weight expressed in terms of gram is called gram molecular weight. Is called gram molecular weight. It's so simple. Whatever the value is given, express that in terms of gram, you will get gram molecular weight. In terms of AMU, it will still be there, but in the micro world. Okay? Acha, now understand one more thing. There is one thing called actual atomic weight or molecular weight. Actual atomic weight or molecular weight. What is that? It is actually weight of one atom or one molecule in terms of gram. In terms of gram, you have to express the weight of one atom or one molecule in terms of gram. That will be called actual atomic weight or actual molecular weight. So let's do that. Who will tell me what is the actual atomic weight of carbon? Come on. Answer please. Be very quick. Come on, I'm watching. Get me the correct answer. Be quick. I believe we have got Harry Potter and Zamir Sheikh giving me the correct answer. But you are not understanding. Actual weight is weight of one atom. Weight of one atom cannot be 12 gram. One atom I can't see, I can't feel. It is so light. It cannot be 12 gram. You really believe that weight of one atom of carbon will be 12 gram? You really 12 AMU, it's okay. Yes, that is 12 AMU, but we want the answer in terms of grams. We want the answer in terms of grams. Correct. That weight of one atom, basically weight of one carbon atom is equal to 12 AMU. Yes, we know that, but we need answer in terms of gram. There will be 12. Convert this AMU into gram. 1.6 10 to power of minus 24. You'll solve it, you'll get 1.92 into 10 to the power of minus 23 grams. That is the weight of one atom. Weight of one atom is almost gone. We can't sense it. We can't feel it. Getting it? So listening to lectures, listening to theory, reading theory is one thing, and solving questions are totally different thing. You'll need an attitude for that. You'll need an aptitude for that. Your problem solving ability should be on a higher level. Without that, nothing is going to come your way. Okay? Ramanna, 12 AMU is what? I need the answer in gram. So convert the AMU into gram. Boys and girls, everyone getting that? All of you getting that or not? Come on. Be very careful. Be very careful. Okay, now let us learn one more thing. For example, 1 mole. What can you call 1 mole? What can you call 1 mole? In terms of molecules, in terms of ions, and in terms of atoms. There are different ways of saying that. 1 mole of molecule is called 1 gram molecule. 1 gram molecule. 1 mole of ions is called 1 gram ion. 1 gram ion. And 1 mole of atom is called 1 gram atom. 1 gram atom. So this is basically a phrase, gram atom. Gram atom means mole. 1 gram atom means 1 mole. 1 Faraday nahi hai. Shruti, this is not Faraday. Faraday will come later on. That is 1 mole charge. 1 mole charge. We are doing 1 mole molecules, 1 mole ions, or 1 mole atoms. Okay, beta? Shruti, getting it? It's not Faraday. Faraday is 1 mole charge. We'll come that later on. So, gram molecule is a phrase. Be careful, bacho. Be careful. है ना? Okay? देखो बच्चों होता क्या है? If I give you a question, that 5 gram molecule oxygen, 5 gram molecule of oxygen. So if they ask you what is the weight of 5 gram molecule of oxygen, now in the examination hall under pressure, people are in different format. देखो बच्चों, 5 gram molecule oxygen. From the childhood, we are trained that whenever we see a number, 5 what? 5 liter, 5 kg, or 5 millimeter or what? We need that 5. So immediately we relate it. So we read it 5 gram, and our mind is searching for number or say name. It simply deletes unnecessary information in the middle. So it will say 5 gram, it will be lost, and you will say 5 gram of oxygen. 5 gram of oxygen. Are you getting it? Today, bacho, you are saying it okay because I write down. But under pressure, people give the wrong answers of the same question. Like how you will decide that whether you will read 5 gram or you will read this gram molecule. This G you will associate here, or this G you will associate here. If you associate here over here, then that becomes 5 mole. But if you associate over here, it becomes 5 gram of O2. And there's a world of difference between the two. Are you getting that, all of you? This is what people do. This is how our brain functions, and they know it. They will play with your psychology. They know that when they give you, like say 10 gram atom. So this means 10 gram. And atom molecule is very normal. 10, say hydrogen. Then you'll say 10 gram of hydrogen. Are you getting it or not? It's not about studying. It's about understanding that how the examiner will be playing with your psyche. The chances of you guys reading 5 gram molecule are very less, and the chances of you reading 5 5 gram of oxygen are very high on that day under pressure. Is that clear? Listen to me carefully, because we keep on doing blunders again and again. चलो ठीक है, देखिए बच्चों. So we'll come to that question. So 5 gram molecules. This is actually gram molecule means this means 5 mole. 5 mole O2. But now why I am writing O2 not O? Why I am writing O2 not O? Because they have given me molecule. So when they give me molecule, I'll write down O2. O2 is the molecule, not O. And when this happens, this will be 5. What is the molecular weight of O2? Come on. 32 equal to what? 160 gram. This is not 5 gram, but 160 gram. Very good, bachu. Very, very good. Very good. Okay. Now, come on. If they give you 5 gram atom, 5 gram atom of oxygen, 5 gram atom of oxygen. This means what? This is gram atom, 5 mole, 5 mole of O. How I am writing O? Because now they have given me gram atom. So oxygen will be written as O, not O2. Very good. This means what? 5 into what? 5 into 16 equal to 80 gram. Equal to 80 gram. 80 gram of O. Okay. How about this one? Say I am giving you 3 gram ion of carbonate. 3 gram ion of carbonate. CO3 2 negative. CO3 2 negative. This means what? Gram ion. 3 mole. 3 mole of carbonate. That means what? 3 into 60. 3 into 60. If you take carbon and 3 oxygen, this will be 60. Getting it? This will be actually equal to 180 gram. 180 gram. Kusuma Kumari, it will be 180 beta, not this thing. Is that clear to all of you, beta? So now there is something called gram molar volume. Gram molar volume. What do you think is gram molar volume? Come on. What do you think is gram molar volume? I'll give a hint. What is actually gram atomic weight? Gram molecular weight. Gram molecular weight. The weight of 1 mole of a compound. Gram molecular weight is weight of 1 mole of a compound. Yes, Deepthi, very good. Very good. So gram molar volume will also be volume of 1 mole of gas at STP. Very good. Gram molar volume. Volume of 1 mole of gas at STP. Very good. Excellent. Very good. 1 mole of a gas, gram molar volume. Pavitra, it's not any compound, it is basically for gases. It is for actually gases. Gram molar volume. Is that clear? Gram molecular weight, weight of 1 mole of substance. Gram molar volume, volume of 1 mole of gas at STP. Will that be okay to all of you? And that will be always how much? That will be always how much? 22.4 liter. 22.4 liter. Okay? ठीक है? Done? चलो आओ. Now I'll teach you a chart. Weight, number of moles, volume of gas at STP in terms of liter, and number of molecules. Number of molecules. Hash means number of molecules. And if you want to come to number of moles from weight, divide by molecular weight or atomic weight, as the case may be, and divide by 22.4 liter if you want to go from volume of a gas to number of moles, and divide by Avogadro number if you want to come back to number of moles from number of molecules. This is called YMAP. Everyone knows that stuff. And if you want number of atoms, you should multiply by atomicity. And what is atomicity? What is atomicity? Number of atoms in a given molecule. Number of atoms present in a given molecule. So what is the atomicity of CO2? What is the atomicity of CO2? 3. Ammonia. 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 4. CH4. CH4. 5. ठीक, done. ठीक है. So this graph I have already taught you, बच्चों, है ना? So बच्चों, I'll request you that I have taught these things in the previous lecture. So I'm giving you homework, बच्चों, है ना? This facility is available right now for the people who are right now on the online. Please watch those 2 or 3 lectures I've taken that time. Remember that? The initial lectures of mole. So we have done many questions based on this chart. Please see those 2 or 3 lectures. In the next lecture, we'll go in the deeper stuff of mole concept. The basics I have taught there, like how to find out number of moles from weight, and how to find out number of moles from volume of the gas, and number of molecules given, how to come back over here. So I have done many questions out there. A humble request to all of you, but you please revise that. Please see those 2-3 lectures again, practice those questions, and come back so that we can do even deeper questions, and we can devote more of our time to more beautiful, more wonderful questions. Will that be okay? All of you will do that? All of you? So I'll stop the class right now, right here, and come back in the next class. We'll do some really good questions, and most of them will be carried from that lecture itself. So wherever we stop there, we'll carry on from there. Is that clear? And come prepared. I want quick answers. It will be a test kind of thing in the class. It will be a question answer session. So fastest fingers first will operate. Sure about that? Chalo, I wish you all the best. You carry on. I'll catch you later on. Okay? Bye, Bichu. Bye. Take care. Bye.